Okay, hello class. Today we're going to go over 10B. So in your Unit 10 packet, you need to turn to the one that says 10B. And then the thing is, your slides are not in the correct order, so just make sure that you're writing on the slide that matches with what's on the screen. So this first slide is the bottom left. So today we're going to talk about parallelograms. So the first thing of parallelograms is we need to know the definition. So you should remember this from middle school, but parallelograms, the definition of it is opposite sides are parallel. And let's actually add both pairs of opposite sides are parallel. So to show that, to show parallel, like if I use my diagram to show it, what we would do is we would put arrows, because remember from Unit 1, arrows means that sides are parallel. And so in symbols, if we write that, in this case, UA is parallel to QD. So those are opposite sides. And QU is parallel to DA, or AD, it doesn't matter. So because these are opposite sides, they're the ones that are across. Then there's four additional properties that you need to know about parallelograms. So the other properties are opposite sides are congruent. So to show that in a different color, you can put tick marks. So I'm going to put 2 tick marks for UA and 2 tick marks for QD. So that shows they are congruent. And then QU and AD. And if I write that in symbols, I would say UA is congruent to QD, and then QU is congruent to AD. The other thing we know are opposite angles are congruent. So to show angles, I'm going to put arcs. So angle Q and angle A are across from each other, so they're opposite, so they are equal. So angle Q is congruent to angle A. And then angle U, if I put 2 arcs, that is equal to angle D, because they are also opposite. We also know, since opposite sides are parallel, by the definition of parallel, consecutive angles are also supplementary. That's one of our angle pairs. So another word for consecutive is same side interior. So we could also call them same side interior. So they're supplementary. Remember, supplementary means adds to 180. And in this case, there's 4 pairs of consecutive angles. So consecutive angles are the 2 angles that are on the same segment. So in this case, angle Q plus angle U add up to 180. Angle U plus angle A add up to 180. Angle Q plus angle D add up to 180. And then the last one is angle A plus angle D add up to 180. Okay, so same side interior. They're on the same side of the line, of the segment in this case, and they're inside the parallel segments. The last thing we know is diagonals bisect each other. So for diagonals bisecting, I have to draw the diagonal. A diagonal stretches across from one corner to the other of a quadrilateral. So we have 2 diagonals for this parallelogram, and I'm going to call the point that they intersect E. And so the diagonals bisect. Bisect, remember, means cut in half or divides into 2 equal segments. So in this case, UE and DE are going to be equal. And then the other diagonal, if we look at it, would be AE and QE would be equal. Now just be careful, UD and QA are not congruent. That's not a property of parallelograms. It's just that the diagonals are cut in half so that the 2 parts of each diagonal are equal to each other. So those are the properties. We know a few other things. For parallelograms, we would also know that alternate interior angles, like these 2, are congruent because we have opposite sides are parallel. So that's just prior knowledge that we also have to apply to these questions. So we're going to use those properties and apply them to problems. So they said find the values of the variables given the shapes are parallelograms. So since the shapes are parallelograms, we can mark the diagrams with the properties. They have to be true. So they're not going to show you the markings when they give you a picture. You can just know that they are true. So in this case, we have 70, A, B, and C, and those all represent angles since they're inside the parallelogram. And so what we know about angles is we know two things. If we look back on our last slide, we know opposite angles are congruent, and we know same side or consecutive angles add up to 180. So that means we know that 70 and B have to be equal. So B has to be equal to 70 because opposite angles are congruent. And then A and C will also have to be equal. Now we also know that consecutive angles or same side interior angles add up to 180. So we know 70 and A have to add up to 180. So to find A, I'm going to do 180 minus 70. And that's going to give me A to be 110. And then once I know A, C also has to be 110 because opposite angles are equal. In the second example, now we're given side lengths. We know that because it's on the outside, so 8 represents this distance. 10 represents the bottom distance of the parallelogram. We know opposite sides are congruent, so I'm going to mark them to show that they're congruent, which means X has to be 10 and Y has to be 8. For the third example, we have diagonals. So what we know about diagonals is that they're bisected, so that the two pieces of each diagonal are equal to each other. So A has to equal 4 and B has to equal 3. And then a little bit more complicated questions. These are more likely what you're going to see. We're given expressions to represent sides, so we have to make an equation and then solve for X. So in this case we have sides. If I mark it, I know opposite sides are congruent. So I'm going to set them equal to each other. I'm going to set 4y plus 21 equal to 6y minus 7. And then I'm going to set 5x minus 16 equal to 3x plus 12 because opposite sides are equal. And then I'm going to solve. So I'm going to solve this quickly. You can pause and solve it yourself if you need a little bit more time. So then y is 14. And x is also 14 in this case. Okay, they won't always come out the same, but in this case they did. Okay, so 3 more examples. So I would recommend pausing the video and actually trying these examples and then looking back at them to make sure that you understand what we're doing. So in this case, we have an x, 6x minus 15, and 3x plus 12, and y. Now, when you have an x and a y, you have to find one of them before you can find the other. So we need to write an equation relating the two expressions with x, which are the angles across from each other. And we know that angles across from each other are congruent, so I'm going to mark that. So I know 6x minus 15 is congruent or equal to 3x plus 12. And then I'm going to solve it again for x. Again, you can pause this if you need to in order to check your work. Oops, and I added wrong. And then we get x is equal to 9. And then to find y, well, in order to find y, we need to know one of the consecutive angles to it. So we need to plug x back in to find this angle. So I'm going to do 6 times 9 minus 15 to get my angle, and we get the angle to be 39, so we know that this bottom left angle and the top right angle are 39, and then we know that y plus 39 has to add up to 180 because they're consecutive or same side interior angles. So then y is 141. Okay. In the second example, we have two angles. They both have an x in it, and they are consecutive or same side interior. So we know they add up to 180. So I'm going to add them to 180. Now, these expressions are on the same side of the equal sign, so we add our like terms. and then I'm going to solve my equation like normal. So I get 17x equals 170. I subtract 10, divide, and then x is 10. And then the last problem, we have two parts of a diagonal. By a parallelogram, we know that the two parts are equal. So I'm going to set 5x minus 7 equal to 4x plus 5. And then I'm going to solve it. So I get x is equal to 12. And one last example for solving, sorry, there's two more after this. So the third last example for solving a parallelogram. So MATH is a parallelogram. Find the missing variables. So again, we know opposite sides are congruent, so I'm going to mark that. And then we also know opposite angles are congruent. So if I mark that. And then we have to remember that same side interior add up to 180. So x is the easiest. X has to be 15. It's opposite to the side. Y also has to be 55 because it's congruent to what's across from it. To get W, I can use either W and 55 or W and this 55. We know that they have to add up to 180 because they're consecutive. So W is 125. Now the hardest one is Z. So to find Z, we know that it makes a straight angle with ATH. So we know these two angles add up to 180. So I have to find this angle. Well, this angle is 125 because it's equal to W. And then 125 plus C has to add up to 180 because they're a linear pair, which means they're supplementary. So then Z is also 55. The other way you could do Z is that because AT and HM are parallel, 55 and Z are corresponding angles, and then they have to be equal since the lines are parallel. Okay, here are the last two examples. So the following is a parallelogram. Find the variables. So in this case, we know 120 is the bottom left, 2x plus 8 is the top right, and 5y is the bottom right. So I first have to find x. Well, you don't have to find x, but we'll first find x. So we know opposite angles are equal, so I'm going to set them equal to each other. And then I'm going to solve for x, so we subtract 8 and then divide by 2, and you would get x is 56. So then we need to find y. So to get y, we have, this is 120. We know this angle also has to be 120 because they're equal. So the consecutive angles, again, add up to 180. So I'm going to add them and set them equal to 180. And then we can subtract 120 and we get 60. And then divide by 5 and we get y is 12. Now just be careful, you can't do 2x plus 8 plus 5y equals 180 because you won't be able to solve it. So just make sure you use the 5y with the 120. And then the last example, WXYZ is a parallelogram. Find the variables. So again, I'm going to mark opposite sides congruent, which means that 2C is equal to 22. So C is 11. The diagonals bisect each other. So I know that A has to be 15. These pieces are equal. And I think that's all we have to find, so we're good. Okay, the second part of the notes is we're going to figure out if we're given a four-sided figure, how do we know this quadrilateral is a parallelogram? So there are 4 ways to determine if you have a parallelogram. So the first way, if both pairs of opposite sides are congruent, then you have to have a parallelogram. The second way is if diagonals bisect each other, then it's a parallelogram by definition. The fourth way is both pairs of opposite sides are congruent, both pairs of opposite angles are congruent. So if both pairs of opposite angles are congruent, then it's a parallelogram. And then if one pair of sides is both parallel and congruent. Now it has to be the same side. So this is a parallelogram. It has to be the same side. There's actually one more based on the definition, so we're going to add one. The other one is both pairs of opposite sides are parallel. And to draw a picture, that means that we're going to have arrows to show, but it has to be both. So that's the key thing. So if you know any of these 5 ways, you can determine that that figure has to be a parallelogram by the properties and definitions. So on here, we're going to determine if these 6 figures are a parallelogram, and then we're also going to justify, because you're going to have to do that on the test and quiz. So number 1, we look, and we have sides. 7, 6, 6, and 7 are sides. So for it to be a parallelogram, opposite sides are parallel. But in this case, it's not the opposite sides. So this is not a parallelogram. Opposite sides are not congruent. For the second one, we look at it. Well, now they gave me angles because they're inside. So they gave me angles, so we need to check that opposite angles are congruent, and they are. 140, 140, 40, 40. So yes, opposite angles are equal or congruent. Okay, number 3, we look at this. So now they gave me the length of the diagonal. So this part is 4, this part is 4, and then the other 2 parts of the other diagonal are both 2. And so we need to know that the diagonals are bisected so that the 2 pieces are equal, and that's true. So yes, diagonals bisect each other. For this one, now we're given a side length and a side parallel, and that does fit one of ours. So this is yes, opposite sides, one opposite side is both parallel and congruent. This one is almost the same as the first one, but in this case, the sides we have, the opposite, are actually congruent. So for this one, it's yes, opposite sides are congruent. And then the last one, well, in this case, one side is congruent, the 11s, and one side is parallel, but they're not the same side. So this is no, not a parallelogram. The same so one opposite side is not both congruent and parallel. Okay, so it has to be the same side. This is actually could be an isosceles trapezoid. If we draw it correctly based on the markings, it would look like this. It's a really bad one. This should be parallel to the other one. So this is parallel. These are both 11. Okay, so it's not drawn to scale, so it could be an isosceles trapezoid. Okay, and then these are a little bit harder examples. So these are the last 4 examples. So in this case, they don't give me any of the options, but they give me angle 2 and 4. And angle 2 and 4 are alternate interior. So I'm going to trace those angles. And we know that if alternate interior angles are congruent, then opposite sides are parallel. Then sides are parallel. So angle 2 and 4, angle 2 is made by AB, and angle 4 is made by DC. So they are parallel. I trace them to figure out which sides are parallel. And then I know angle 1 and angle 3 are congruent. So I'm going to trace angle 1. I'm going to trace angle 3. And if I trace them, that shows me that angle 3 is created by side BC. And angle 1 is created by side DA. So I'm going to mark those parallel. And now I can see that opposite sides are parallel. So this is yes, because opposite sides are parallel. So these are the hardest ones because they're not giving you the exact information that we need, but you have to use prior knowledge to figure it out. Okay, so for this one, it's kind of the same we did on the last test. We have one side parallel one side marked congruent by the dashes, but it's not the same side, so this is no. Again, it's the same side or pair of sides is not both parallel and congruent. And then for the last two, okay, so again, we don't have any of the information. We don't have opposite angles, but we have another type of angle. 62 is here and 62. So these are congruent. Remember from Unit 4, these are corresponding. So again, if I trace those angles, then the sides that they make of the parallelogram is the top and bottom. So those lines are parallel. I'm going to trace the other 62s, this one and this one. Okay, these are also corresponding angles. They're in the same place. So the sides that they make are the left and right. So these opposite sides are also parallel. So this is a parallelogram. Yes, opposite sides are parallel because of the consecutive angles. Or sorry, not consecutive, the corresponding angles. Okay, and the last one, so I have tick marks for congruent side, and then I also have these angles. Remember, they're alternate interior. So I'm going to trace the two angles to see which sides of the parallelogram, and it's top and bottom, so I'm going to mark them parallel, and then it does fit one of our ways now. So we're going to say yes, one pair of sides is both opposite and parallel and congruent. So that is the property of parallelograms and how you apply them. Tomorrow in class we will be doing 10C to practice with this.